All right, we're going to work with some sum and difference formulas. So in the yellow boxes are the 6 formulas for the sum and difference. So I'm just going to highlight this first one here. If you have two angles that are adding together, this notation here represents the Greek letter alpha, so A. And then this letter in the Greek system is called beta. So think of that letter as your B. So if we take the cosine of alpha plus beta, we can rewrite it so it is in this sum and difference formula. And then we can use our unit circle to find those cosines and sines of alpha and beta. So again, please make sure you know these 6 formulas. They are not formulas that you have to memorize. So you don't have to memorize. All right, so we're going to go ahead and move down to the first example. So it's saying we have this cosine of 15 degrees, and 15 degrees is not on the unit circle. So right here is about 15 degrees. And we want to find out what is the cosine value for 15 degrees. So what we're going to do is we're going to use two angles that are on the unit circle that either add or subtract to give us 15 degrees. And we're going to use a formula from that previous slide. So if we think about this, 60 degrees and we subtract 45, we get 15 degrees. 60 degrees and 45 degrees are both angles on the unit circle. So I'm just going to go ahead and change colors here. Here would be 45 degrees. It has the ordered pair square root of 2 over 2, square root of 2 over 2. 60 degrees on the unit circle has the ordered pair 1/2, comma, square root of 3 over 2. And if you remember from the point on the unit circle, your x and y, the x is your cosine value and then your sine is your y value. So we're going to go ahead and look back up into our formulas, and we're going to use this formula right here. We're going to say the cosine of 60 degrees minus 45, and then substitute our alpha and beta in. So I'm going to write the formula first. So the cosine of alpha minus beta equals the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. So this is going to be our alpha, 60 degrees, and that is going to be our beta, our b, 45. So let's go ahead and substitute it in. So the cosine of 60 degrees minus 45 equals, now sub in your alpha, 60 degrees, times the cosine of your 45 degrees, and I'm just going to erase this here so we have some room, plus the sine of 60 degrees times the sine of 45 degrees. So we're substituting into the formula above. Now we do know those 4 values from the unit circle. So what is the cosine of 45 degrees, sine of 45 degrees, cosine of 60, sine of 60? Those we already identified up in our drawing. So let's start with 60 degrees. Here's 60 degrees, and we want the cosine. That's 1/2, so we substitute that in, 1/2. Then it says take the cosine of 45. So here's 45 degrees, and its value is square root of 2 over 2. Plus the sine of 60, and that value is square root of 3 over 2. And then the sine of 45 degrees, that's your y value, square root of 2 over 2. Then we're going to simplify. So we're going to multiply those fractions across. So we get the square root of 2 over 4 plus square root of 6 over 4. Those two fractions have like denominators, so we can go ahead and combine those numerators. We get the square root of 2 plus the square root of 6 over 4. So the exact value for the cosine of 15 degrees up here in the pink is now the square root of 2 plus the square root of 6 all over 4. Now, a question from your textbook. Can I use my calculator to verify that we get that same answer? So you could type in the cosine of 15 degrees and you're going to get that decimal value, or you can type in your answer and get that same solution. So you could check that if you'd like. Let's go to example 2. So now we have the cosine of 80 degrees times the cosine of 20 degrees plus 80 degrees times the sine of 20 degrees. And we want to use our formulas above. So watch that we have an alpha and a beta, an alpha and a beta. And we have to pay attention to, we have a cosine times a cosine plus a sine times a sine. So we're going to go up to our formulas and find the formula that works with that. So I'm just going to erase these here. And we're looking for when we have a cosine and another cosine adding a sine times a sine. So what we've been given is this right side of the equation, and we want to work backwards to the left side of the equation. So I'm just going to go ahead and write that formula down. So what we have in the red is the cosine of alpha minus beta equals the cosine of alpha, the cosine of beta, plus the sine of alpha and the sine of beta. And now we sub in what we know. So 80 degrees is going to be our alpha, and 20 degrees is going to be our beta. And we're going to substitute it into this left side of the equation. So the cosine of 80 degrees minus 20 degrees. And then we can simplify that, which is 60 degrees. Now 60 degrees is one of our special angles on the unit circle. Here is 60 degrees. It has the order pair 1/2 square root of 3 over 2. Remember, the x is your cosine value. So what is the exact value for the cosine of 60 degrees? 1/2.